Assembled for Sha-Tin Central Contract 1121 is the Dragages, Leader, Bouygues joint venture, who have many years' experience of projects of this nature, both in Hong Kong and around the world. Leading the team is Dragages, who with their parent company Bouygues employ over 50,000 staff worldwide. Dragages have over 50 years of experience in Hong Kong and are renowned for their technical innovation and excellent safety record. Leader has considerable experience, being the only local Hong Kong company with IMT experience and a good relationship with the Marine Department, recently completing one section of immersed tunnel for the Central Wan Chai Bypass project and the Hong Kong CG submarine gas pipeline across Victoria Harbour. Volca International is a renowned IMT marine works contractor with worldwide experience, with the most recent IMT contracts being Coatzacoalcos Tunnel in Mexico and partnering with Bouygues UK for the new Tyne crossing in Newcastle, England. Works will begin for the construction of the marine cofferdam and the land cofferdam on the northern landfall site. One flat-top barge with spuds will work within the cofferdam area to install the mini piles for the launching beams. The launching beams will be installed over the existing fender piles to avoid removal. The launching beams will be installed at the west and east of the cofferdam, continuing to install mini piles for the working platform. The working platform will be installed and pipe piles installed for the cofferdam. Fender piles will be installed around the outside of the cofferdam to protect it from ship collision during excavation. Using this method significantly reduces the amount of land reclamation to be carried out. At the same time, excavation of the landside cofferdam and the north ventilation building is constructed. Excavation and concreting works will then take place inside the cofferdam. After clearance works, the excavation of the existing finger pier will be as per NTR's base scheme. The foundation of the new vertical seawall constructed and existing seawall demolished to make way for the IMT units. Piles installed and the new seawall constructed and backfilled. The works will then be stopped to allow dredging to be completed for the immersed tunnel at the northern landfall area. Once the IMT works are completed, the remaining front row of piles will be installed, precast slab lowered into position and final surfacing finished. At the southern landfall area, 5 different works areas will be subdivided into 3 work fronts in terms of their different site possession and vacation dates in accordance with the CCM requirements. At Works Front 1, a hydrographic survey and marine site investigation for the target dredging profile will be carried out and silk curtains installed. After confirmation of the dredge profile, the rock foundation and installation of the concrete seawall blocks will commence. Backfilling will be carried out until the final reclamation level is reached. Pre-treatment works, pre-drilling and guide walls are established, followed by diaphragm wall construction with toe grout for water tightness. A pumping test will be conducted to prove water tightness, and bulk excavation is carried out concurrently with the installation of an ELS system. The reinforced concrete tunnel box will be constructed by conventional methods together with the installation of waterproofing system. The initial setup for Works Front 2 will match Works Front 1. The temporary relocation of some mooring areas will be carried out where overlapping occurs with the dredging footprint. Prevention of impact to the stakeholders in the Causeway Bay Typhoon Shelter is of utmost importance. Therefore, the period of temporary relocation will be no longer than 1 month. After relocation works, the trench dredging for temporary seawall foundation will be conducted. The removal of the existing breakwater will be carried out by both land and marine plants concurrently. The breakwater will be removed by open cut method with the slopes maintained at 1:20 at both sides. The construction of the cofferdam will continue as per the method of Works Front 1 construction. When finished, the breakwater will be reinstated to the same level and profiles as the existing. Phase 5 moorings and anchorage rearrangement will be implemented once site possession of the works area is gained. Works will continue as per Works Fronts 2 and 3 for the construction of the cofferdam and the concrete tunnel box. A 5-meter gap will be left between the tunnel box and ME4 for the connection joint. The box will be preloaded with backfill material to induce settlement to the unit. The remaining 5 meters of tunnel box will be concreted, forming the connection between the cofferdam and ME4. The casting facility will be located at the existing Sheko quarry. A mobile batching machinery and equipment area and site office will be set up at the bottom of the existing zigzag access road within the quarry. Haul roads will be constructed to the barging point at the northwestern corner of the quarry and to the steel reinforcement at the northern headland. Another haul road will connect the mobile batching plant with the upper platform of the casting basin. 2 new dock gates will be fitted into the refurbished gate sills, allowing draining of the basin for site preparation works. A barging point will be set up at the northwestern corner of the quarry site to provide a berth for transporting materials. The barging point is a critical facility for the casting yard, as construction materials shall be delivered via marine access only. The 10 immersed tube tunnel elements are founded on the basin floor. Precasting of the IMT units will ensure the utmost in the performance and quality. Cooling pipes will be installed inside the IMT units to guarantee concrete curing and reduce thermal cracking. After casting of the IMT elements, including the waterproofing system and the bulkhead installation, the basin will be flooded with seawater by opening the sluice gates installed in the dock gate abutments. As the basin is flooded, the IMT units will be checked for water leakage. The main dock gate will be floated, removed and shifted outside the channel by winches and tug assistance. The immersed tunnel units will then be floated and towed to the open dock gate using winches. Tugboats will then take over the towing process and transport them to their final founding position in Victoria Harbour in 2 stages. The first stage of 15.5 kilometres to Junk Bay and the second stage of 8.5 kilometres to the immersion location. Transport operations will be planned and executed dependent on the weather and wave forecast. Bollards and lifting points will be installed on the tunnel elements for towing and positioning. These will guide the winch wires and lifting points for lowering of each element. The tunnel element is supported vertically while floating by 2 catamarans and 2 vertical winches per catamaran. 2 winch towers will be installed on the roof of the tunnel element to control the horizontal positioning. Once preparation works are completed for the immersion process, water will be let into the ballast tanks. The element will immerse at this point. By using the winches on the catamaran, the element is lowered step by step in vertical and horizontal directions until in its final position. The catching pin will be connected. Divers will do an inspection around the immersion joint and Gina gasket and connect the pulling cylinder. The element is pulled to the previous element or to the cut and cover section by using the pulling cylinder. The foundation of the tunnel element is based on the sand flow principle. The tunnel element will be immersed on jacking pins, secured on foundation pads laid on the seabed of the dredge trench. A mixture of sand, cement and water will be pumped through pipelines in the concrete floor slab of the tunnel element to fill the void between the dredge profile and the tunnel element. Locking fill of granular material will be placed on both sides of the IMT element to stabilize the unit. Backfill will proceed following the placing of logging fill. The general fill will be delivered and placed below water by derrick barges below water to mitigate water pollution. The sequence of immersion starts with tunnel element 10, then tunnel element 9, followed by tunnel elements 1 to 8. Marine safety to public and commercial craft is of great importance during IMT operations. The fairway will be shifted first to the south and then to the north to avoid any collision during the works. During the installation of elements 4 and 5, an extra fairway will be provided for cruise liners operating in the channel. After installation of the closure joint, the fairway will be shifted back to the original position. The joint venture proposes 2 alternatives for the northern and southern landfall sections. At the northern landfall, it is proposed to reduce significantly the extent of the temporary reclamation compared to what was proposed under the CCM. This reduces the marine cofferdam by 60 meters and is replaced by an IMT precast element. The dredging for the IMT will be undertaken inside a sheet pile wall to reduce environmental impact to the harbour. Using an IMT unit in this area will ensure quality, increase safety to workers and marine traffic, and reduce the amount of labour employed compared to traditional cast in situ methods. Ultimately, this saves construction time. The tunnel element is then floated in using a combination of catamaran barges and winches connected to the northern landfall. At the southern landfall, it is proposed to replace the marine cut and cover section with immersed tunnel elements all the way to ME4. A double pipe pile wall will be installed inside the Causeway Bay Typhoon Shelter to remove all the works associated with the marine cut and cover works. Seawall blocks are installed and the breakwater is demolished. The marine cofferdam is made of double skin walls designed to cater for marine collision from other vessels. Tunnel element 13 will be floated into the marine cofferdam for temporary storage. A temporary breakwater barrier will then be constructed using the old dock gate from Sheko, reducing construction and demolition materials. Open dredging will be carried out inside the Causeway Bay Typhoon Shelter for Tunnel Element 13, which is then floated into its final position. The breakwater and seabed level will then be reinstated. After installation of Tunnel Element 13, a typical cast in situ underwater closure joint will be constructed for the final connection between ME4. This alternative reduces the total volume of materials passing through the Causeway Bay Typhoon Shelter and significantly the size of the reclamation, reducing marine traffic and impact on the stakeholders in this area. For the new configuration, the additional IMT elements will be prefabricated in the Sheko casting basin at the same time as the original 10 elements. Therefore, a new casting basin is not required. Rockfill will be carried out for the lower platform as draining of the basin and site investigation work are completed. This will provide an adequate working area for the casting of the additional elements needed for the option. A sump pit will be provided near the small dock gate to receive rainwater. Both alternative methods provide significant time saving, less environmental impact to the project, and enhanced marine safety due to fewer barge movements in the area. Dragages and their parent company Bouygues have formed a joint venture with a strong management team already mobilized for the project. They have in place the team, resources and world expertise in immersed tunnel construction to ensure the project is on schedule and within budget without incurring any adverse public sentiment. Their philosophy and commitment to safety stands as a testament to the partnering with the MTR and their joint vision in constructing an environmentally aware system and also ensuring that the good name of the MTR is not endangered.